In Hawkins, strange things happen. Today, I face mysteries that even upside down can explain. Rational inequalities. As a math investigator, I promise to uncover the truth behind every fraction, every sign, and every solution. I commit to making this mystery clear and logical, because math isn't a monster, it's a puzzle we can solve together. So, let's hop into the cases and uncover the math problems hiding behind these equations. Just like solving mysteries, math inequalities help us find all possible answers, not just one. The goal of studying inequalities is to understand how to compare quantities and determine every value that make a statement true. Unlike equations that show equality, inequalities help us describe ranges or conditions when something is greater, smaller, or even equal. For example, if we have x plus 3 greater than 7, it means any value of x greater than 4 will make this statement true. So, inequalities don't just give one answer, they help us see all the possible values that work. That's the goal of studying inequalities, discovering the full picture, not just a single solution. Let's talk about the basic concepts of rational inequalities. A rational expression is a fraction with variables in the numerator, denominator, or both, like 2x plus 5 over x minus 3. Critical points are values of x that make the numerator 0 or the denominator 0. If the numerator is 0, it might be part of the solution. If the denominator is 0, it's not included. Next, we find intervals, sections of the number line divided by the critical points. We test each interval to see if it satisfies the inequality. Finally, we combine all intervals that make the inequality true, using parentheses if a value isn't included, like when the zero denominator equals 0. Definition: an inequality compares two expressions using symbols like greater than, less than, or equal to. It helps us find which values make a statement true. Case 1. X plus 1 over x minus 4 is greater than 0. Let's solve this rational inequality. Step 1. Find the critical points. To find the critical points, set the numerator and denominator equal to 0. That gives x equals negative 2 and x equals 4. Explanation of critical points. These points divide the number line into three intervals, from negative infinity to negative 2, negative 2 to 4, and 4 to infinity. Number line or critical value. Here's the number line showing our critical points at negative 2 and 4. Notice they separate the intervals. We'll test. Step 2. Test the intervals. Now, we teach each interval using a sample value. For example, if x equals negative 3, the result is positive, so the inequality is true in that interval. Interval 2. Now, let's test the intervals for the inequality x minus 4 over x plus 2 is greater than 0. For the interval, we'll use negative 2, 4. Let's pick x equals 0. Substituting gives 0 minus 4 over 0 plus 2 is equal to negative 4 over 2, and that turns to negative 2. Since negative 2 is less than 0, the inequality is not satisfied in this interval. For the interval 3, we'll use 4 infinite. Let's pick x equals 5. Substituting gives 5 minus 4 over 5 plus 2 is equal to 1 over 7. Since 1 over 7 is greater than 0, the inequality is satisfied in this interval. Step 3. Write the solution. The inequality x minus 4 over x plus 2 is greater than 0 is true when x is less than negative 2 or greater than 4. In interval notation, the solution is negative infinite, negative 2, union 4, infinite. For case 2, we have the inequality 2x plus 5 over x minus 3 is less than 0. We need to find where the expression is less than 0, meaning where it's negative. We'll solve this by finding the critical points where the numerator or denominator equals 0, and then the test intervals to see where the expression becomes negative. Step 1. Find the critical points. The critical points are the values of x that make the numerator or denominator equal to 0. Set the numerator to 0. 2x plus 5 is equal to 0, giving x equals negative 2.5. Set the denominator to 0. X minus 3 is equal to 0, giving x equal to 3. As you can see here, this is the critical value or number line. So, our critical points are x equal to negative 2.5 and x equals to 3. These points divide the number line into three intervals: negative infinite, negative 2.5, negative 2.5, 3, and 3 infinite. Step 2. Test the intervals. Now, let's test the intervals for the inequality 2x plus 5 over x minus 3 is less than to 0. For the interval 1, negative 2.5, 3, let's choose x equals to 0. Substitute 2x 0 plus 5 over 0 negative 3 equals to 5 over negative 3 is equal to negative 5 over 3. Since it's negative 5 over 3 is less than 0, this interval is part of the solution. For the interval number 2, negative 2.5, 3, let's choose x is equal to 0. Substitute 2x 0 plus 5 over 0 negative 3 is equal to 5 negative over negative 3 is equal to negative 5 over 3. Since it's negative 5 over 3 is less than 0, this interval is part of the solution. Next, for the interval number 3, 3 infinite, let's choose x equal to 4. Substitute 2x 4 plus 5 over 4 minus 3 is equal to 13 over 1. That turns into 13. Since 13 is greater than 0, this interval is not part of the solution. Step 3. Write the solution. So, the inequality is satisfied when negative 2.5 less than x less than 3. In interval notation, the solution is negative 2.5, 3. Case 3. Let's solve the inequality x squared minus 1 over x minus 6 is greater than 0. Step 1. Factor and find the critical points. The numerator is a difference of squares. X squared minus 1 is equal to x minus 1 and x plus 1. So, the inequality becomes x minus 1, x plus 1 over x minus 6 is greater than 0. Setting each factor equal to 0 gives x equal to negative 1, x is equal to 1, and x is equal to 6 as our critical points. As you can see here, this is our critical value or number line. We use negative 1, 1, and 6, and that turns into 4 intervals. Step 2. Divide the number line into intervals. These points divide the line into 4 intervals: negative infinite, negative 1, negative 1, 1, 1, 6, and 6 infinite. Step 3. Test the intervals. Let's test the first interval, negative infinite, negative 1, using x is equal to negative 2. Substitute negative 2 minus 1, negative 2 plus 1 over negative 2 minus 6 is equal to negative 3, negative 1 over negative 8, and that is equal to negative 3 over 8. Now, let's test the second interval, negative 1, 1, using x equals 0. Substitute into the inequality x squared minus 1 over x minus 6 is greater than 0. That gives 0 minus 1, 0 plus 2 over 0 minus 6 is equal to negative 1, 1 over negative 6. And that is equal to 1 over 6. Since 1 over 6 is greater than 0, the inequality is satisfied in this interval. Next, let's test the interval 3, 1, 6, using x equal to. Substitute into the inequality x squared minus 1 over x equals 6 greater than 0. That gives 2 minus 1, 2 plus 1 over 2 minus 6 is equal to 1, 3 over negative 4 equal to negative 3 over 4. Since negative 3 over 4 is less than 0, the inequality is not satisfied in this interval. Finally, let's test the last interval for case 3, 6 infinite, using x equal to 7. Substitute into the inequality x squared minus 1 over x minus 6 is greater than 0. That gives 7 minus 1, 7 plus 2 over 7 minus 6 is equal to 6, 8 over 1, and that is equal to 48. Since 48 is greater than 0, the inequality is satisfied in this interval. Step 4. Write the solution. The inequality x squared minus 1 over x minus 6 is greater than 0 is satisfied when negative 1 less than x less than 1 or x is greater than 0. In interval notation, the solution is negative 1, 1, union 6, infinite. Let's move on to case 4. 3x minus 2 over x squared minus 9 is less than 0. Step 1. Factor and find the critical points. Let's solve the inequality 3x minus 2 over x squared minus 9 is less than 0. First, factor the denominator. Since x squared minus 9 is a difference of squares, we write it as x minus 3, x plus 3. So, the inequality becomes 3x minus 2 over x minus 3, x plus 3 is less than 0. Now, find the critical points. For the numerator, 3x minus 2 equals 0, giving x equal to 2 over 3. From the denominator, x minus 3 equals 0 gives x equal 3, and x plus 3 equals 0 gives x equal to negative 3. Step 2. Divide the number line into intervals. The critical points negative 3, 2 over 3, and 3 divide the number line into 4 intervals: negative infinite, negative 3, negative 3, 2 over 3, 2 over 3, 3, and 3 infinite. We'll test one value from each interval to determine where the inequality 3x minus 2 over x squared minus 1 less than 0 is true. So, our critical points are x equal negative 3, x equal 2 over 3, and x equal 3. Step 3. Test the intervals. Interval 1. Interval 1, negative infinite, negative 3. Let's pick x equal to negative 4. 3 multiplied negative 4 minus 2 over negative 4 squared minus 9 is equal to negative 12 minus 2 over 16 minus 9 is equal to negative 14 over 7, and that is equal to negative 2. Since it's negative 2 less than 0, the inequality is satisfied in this interval. Interval 2, negative 3, 2 over 3 using x equals 0. Substitute into the inequality 3x minus 2 over x squared minus 9 is less than 0. That gives 3x 0 minus 2 over 0 squared minus 9 is equal to negative 2 over negative 9, and that is equal to 2 over 9. Since 2 over 9 is greater than 0, the inequality is not satisfied in this interval. Interval 3, we need to determine the sign of the expression 3x minus 2 over x squared minus 9 is less than 0 in each of these intervals. Let's use 2 over 3, 3. Let's pick x equal 1. 3 multiplied 1 minus 2 over 1 squared minus 9 is equal to 1 over negative 8, and that turns to pot 1 over 8. Since it's pot 1 over 8 is less than 0, the inequality is satisfied in this interval. Last interval for case 4. Interval number 4. 3 infinite. Let's pick x equal 4. 3 multiplied 4 minus 2 over 4 squared minus 9 equal to 12 minus 2 over 16 minus 9, that is equal to 10 over 7. Since 10 over 7 is greater than 0, the inequality is not satisfied in this interval. Step 4. Write the solution. The inequality is satisfied when x less than negative 3 or 2 over 3 is less than x less than 3. Therefore, the solution in interval notation is negative infinite, negative 3, union 2 over 3, 3. Case 5. X plus 7 over x squared minus 10 is greater than 0. Step 5. Factor and find the critical points. The denominator is a quadratic expression. We need to find two numbers that multiply to negative 10 and add to 3. These numbers are 5 and negative 2. So, x squared plus 3x minus 10 is equal to x plus 5, x minus 2. The inequality becomes x plus 7 over x plus 5, x equal to is greater than 0. Numerator, x plus 7 equals 0, and that is equal to x equal negative 7. For denominator, x plus 5 equals 0, that is equal to x equal negative 5. The last one, x minus 2 equals 0, and that is equal to x equal 2. Step 2. Divide the number line into intervals. The critical points negative 7, negative 5, and 2 divide the number line into 4 intervals. Negative 8, negative 7, negative 7, negative 5, negative 5, 2, and 2 infinite. As you can see here, this is our critical value or number line, and that's where we got our 4 intervals. And these intervals will be tested to determine where the inequality x plus 7 over x plus 5 x minus 2 is greater than 0 is satisfied. Step 3. Test the intervals. Interval 1. Negative infinite, negative 7. Let's pick x equal negative 8. Negative 8 plus 7 over negative 8 plus 5 and negative 8 minus 2 equal to negative 1 over negative 3, negative 10, and that is equal to negative 1 over 30. Since both negative 1 over 30 is less than 0, the inequality is satisfied in this interval. Interval 2, negative 7, negative 5. Let's pick x equal negative 6. Negative 6 plus 7 over negative 6 plus 5 and negative 6 minus 2 is equal to 1 over negative 1, negative 8, and that is equal to 1 over 8. Since 1 over 8 is greater than 0, the inequality is satisfied in this interval. Interval 3, negative 5, 2. Let's pick x equals 0. 0 plus 7 over 0 plus 5 and 0 minus 2 is equal to 7 over 5 negative 2, and that is equal to 7 over negative 10, and that is equal to both 7 over 10. Since both 7 over 10 is less than 0, the inequality is satisfied in this interval. Interval 4, 2, infinite. Let's pick x equal 3. 3 plus 7 over 3 plus 5 and 3 minus 2 is equal to 10 over 8, 1 equal to 10 over 8 is equal to 5 over 4. Since 5 over 4 is greater than 0, the inequality is satisfied in this interval. Step 4. Write the solution. The inequality is satisfied when negative 7 less than x less than negative 5 or x greater than 2. Therefore, the interval notation is negative 7, negative 5, union 2, infinite. 5 mysteries, 5 solutions, but one commitment to never stop solving. Math may look strange at first, but behind every equation lies a pattern, a truth, a chance to understand more. I commit to learning, to teaching, and to facing every challenge with logic and courage. Because in the world of numbers, just like in Hawkins, even the strangest things make sense when you look closely. 5 mysteries, 5 solutions, but one commitment to never stop solving. Math may look strange at first, but behind every equation lies a pattern, a truth, and a chance to understand more. I commit to learning, to teaching, and to facing every challenge with logic and courage. Because in the world of numbers, just like in Hawkins, even the strangest things make sense when you look closely enough.